Good morning. How you guys doing today? Fantastic. Small class today. Three goods and one all right. I'll take it. We don't have much left to the school year. Actually, pre-calculus is wrapping up pretty quickly. And for a few of you who took the ACTs and chose math as your first option for your final exam pass, really you just probably have this 10.3 lesson left and the Unit 10 test, which is assigned this week, and that's it. So not a lot left to really go over. I was thinking that maybe today, because not many people have turned in that homework assignment, that we could look at that together today. Does that sound like something you guys would be interested in? We don't usually do that in our live classes. Okay, good. But I thought that it might be a nice way to wrap up the school year here is just take a look at that last homework assignment together. Really make sure you kind of grasp those understandings of your limits and before you go and take your test later this week. All right, with that being said, we'll get started with that in just a little bit. A few more announcements. Don't forget that May 20th is this week's Sunday, and that is when everything has to be turned in by except the final. So we do want to make sure that that Unit 10 test, and if you have any missing assignments, which I don't think anybody in here does, but someone's watching the recording, if you have any missing assignments, those have to be turned in by midnight on Sunday. As well as this 10.3 lesson, which hopefully we can wrap up today, so we don't have to worry about that. And then that Unit 10 test needs to be taken care of as well this week. So just double check your grade book, make sure everything looks good. You got no zeros in there for anything. And then next week, May 25th, by 4 p.m. is that final exam deadline. Now, in Thursday's class, for those that are taking the final exam, so I won't take attendance Thursday, so if you don't have to take the final exam, you do not need to attend Thursday's class. But for those who are taking the exam, I'll go over what you can expect in Thursday's class on that exam. So it'll be a shortened class on Thursday for sure. Attendance is not mandatory, but if you're taking the final, I would highly recommend that you come just to get an idea of what's all going to be on it. The last thing I just want to mention, and I know it really is not going to affect any of you in here too much, but I just wanted to say thank you for a fantastic year of learning. It's actually going to be my last year with WVL teaching math. I've decided to accept a different position next year, so a little nervous and excited, but I just wanted to wrap up and say thank you so much for a fantastic year of learning and ending on a high note. You guys were such a joy in class and definitely made it worth waking up every morning and coming in front of my computer nice and early. So thank you for definitely a great year. Thanks, guys. Exactly, right? So a lot of you, I don't teach AP Calculus at WVL anyway, so if that's the next step, obviously you wouldn't necessarily have me, and then some of you are graduating, so you wouldn't have me anyways. So like I said, doesn't really affect you guys, but I just wanted to thank you for a great year nonetheless. I've been here 11 years, so over a decade, really long time. So just kind of starting the next chapter of my life for maybe the next decade. We'll see. But you can't get rid of me that easily because we do have to finish up with some of the stuff here still in this unit. And obviously I'll still be around to answer any questions you guys have. I'll still be around during finals week. I'll actually be around till June 5th. June 5th will be my last day with WVL. So I'll be around for a little bit still, a couple more weeks. So if you need letters of recommendation or anything like that, make sure you hit me up. I'll gladly write anybody letters of recommendation that they might need or can store up or anything like that. Nice, Isaias. Yeah, unfortunately, you're not that lucky. That would be a pretty awesome going away present, though, wouldn't it? Gotta make sure you understand your limits and before I let you go, and your your integrals, definite integrals, and all that good stuff. So can't let you get off the hook without mastering those concepts first. All right, but just like I promised, let's open up that 10.3 homework assignment. Why don't you give me a green check when you have that open, and we'll go through these 9 questions together as a group. Hopefully you all get your 100% and we'll have you on your way for today. All right, and Rebecca, I know you're joining us a little bit late here. We are taking a look at that 10.3 assignment. I know you already turned yours in, but if you got any wrong on it, we can. If you take the notes and you turn them in to me, I can give it back to you for full credit. Okay, so yeah, yeah, probably not going to work out for you, Isaias there. All right, everyone's good, so let's go ahead. Use the given graph to determine the limit if it exists. So real tiny underneath here, under the graph here, we see the 2 limits that they're asking us to find. It looks like we're asking to find the limit as x goes to 2 from the left-hand side and as x goes to 2 from the right-hand side. So let's start with the left-hand side of that graph first, since it's the first one they mention. So if I start from the left-hand piece and I work my way towards that 2 value on the x-axis, what is that graph approaching? We got 1 vote for 3. What's everyone else thinking? 2 votes for 3. 3 votes for 3. Yeah, that's definitely going to be a 3. It's cutting right through that y-axis at 3. By process of elimination, we should be able to choose that last choice, but let's just verify that from the right-hand side, it actually is going to a -2. So does that graph match up with that answer choice? As we approach x going to 2 from the right-hand side, is the limit -2? Yeah, it is. Let's see, can I squeak number 2 on the same slide? Yes, I can. Awesome. All right, use the graph to determine the limit if it exists. This time we're only looking for the limit as x goes to 2 from the right-hand side. Notice the little plus sign here. What is the limit as x goes to 2 from the right-hand side? We got 1 vote for 4. I'm going to highlight my graph. With 2 votes for 4, 3 votes for 4, yeah, that is definitely going to 4. Okay, what if they throw just a piecewise function at us? Can we find the limit just using a piecewise function? So here it asks to find the limit as x goes to -8 as a whole. So if it's asking us what's the limit as x goes to -8 as a whole, and you're only given the functions here and not a graph, what can you do to figure out this answer? Substitution. And what are we going to substitute into? Both of them. If we're going to substitute into both of them, what exactly are we looking for then? So if I substitute into that first one, and if I substitute into the second one, what exactly am I looking to happen? You're looking for them to be the same. Very good. Okay, let's see. Are they going to be the same? What is -8 plus 9? And what is -7 minus -8? Yeah, don't forget that double negative in there turns into a positive. It is a 1. So if they're the same answer, what does that mean for the limit? It exists and it's 1. Yeah. The limit is 1. Good. All right, question 4, use graphs and tables. All right, so I'm going to go bring up GeoGebra. Well, actually, you know what? I think I can get away with just using the graphing calculator in here for this one. We'll see if it's going to play nicely. Y equals 1 divided by x minus 4, but we want to make sure x minus 4 is all in the denominator. Okay, we're looking for x goes to 4 from the left. All right, so I'm going to go ahead and kind of center my graph here so that 4 value is kind of right in the middle of what we're interested in. So first of all, what is the limit as x goes to 4 from the left-hand side? -infinity. Okay, so that really only gets rid of one of our answer choices, which is the last one. The second piece is to identify any vertical asymptotes. Do we have any vertical asymptotes here? Oh, actually it gets rid of 2 choices, sorry. Yeah, we have x equaling 4. Good. So x equaling 4 and a limit of -infinity means it must be that third answer choice. And we can physically see that vertical asymptote at x equaling 4. Algebraically, you can find that using the denominator. Right? If you set that equal to 0, that's your problematic spot or area, and that's where vertical asymptotes will occur. So adding 4 to both sides, you can see algebraically that yes, that vertical asymptote is happening at x equals 4. All right, we are just cruising. We finally are coming upon those essay questions here, but these should look a little bit familiar. We have to find the limit as x goes to infinity of this function here, and then as x goes to -infinity of the function. So what are some tactics and strategies you want to take here to help you find these limits? You can definitely graph it. Is there another approach you could take besides graphing? There is another approach you could take. We actually saw an example similar to that. Let's see. In our book, what you could do. Okay, hold on, I forgot it. Add an extra parentheses here. What you could do is you could like break it up and try to use substitution. You can split this one up, yep. And we know that sine of x over x, the limit as x goes to infinity, it should be 0, right? Or 1, one of the two. I can't remember what the example actually was there. But you could try to split that up to simplify it. Aw, look at this wonderful pretty graph here. All right, I'm probably going to have to zoom out, center this quite a bit. Maybe I'll zoom in just a little bit. All right, let's start with part A. What is the limit as x goes to infinity for this function here? So as x gets increasingly large, what is the graph approaching? It's centering around 1. It's kind of oscillating back and forth a little bit, but it's getting closer and closer to that 1 value. So we would say the limit there is 1. And if you split it up, remember we would get that same thing because you'd have x over x plus sine of x over x. And sine of x over x, we knew that limit was 0. So 1 plus 0 gave you that 1 limit, right? When we used the substitution and split that up, so to speak. All right, part B, what is the limit as x is going to negative infinity? So as x is getting increasingly smaller, what is the limit? Yeah, 1 again. Yeah, nothing changes with that infinity or negative infinity when we split it up there either. It would still be 0 for that sine of x over x. So we get the same output either way. It should be 1 and 1. All right, question 6 here. Use graphs and tables to find the limit and vertical asymptotes. No, you do not need to put the graph in. Nope. So you only would graph it on your own and then just tell me what the limit would be. You do not need to graph these. And the same thing with the Unit 10 test. If you need to graph to find the limit, you do not need to supply the graph. Right? You just need to strictly tell me what the limit is when you are looking at it. So hopefully that helps a little bit when it comes to that test as well. You can use GeoGebra or your graphing calculator to graph things pretty quickly, but you don't need to put that in as part of your answer either. Okay, the next one here, let's switch out my function. I got x divided by, just make sure that that x minus 3 is getting put inside parentheses because we want all of that clumped in the denominator. All right, let's start with the vertical asymptote first. I know it didn't appear first in my question, but let's find that. What is the vertical asymptote of this graph? Yeah, x equaling 3. Make sure you put the x equals in. That way we know it's prompted for a vertical line versus a horizontal. But yep, we definitely see that it's happening on that x equals 3. So now we can find the limit. We're looking for just the limit as x goes to 3 from the right-hand side. So only from the right-hand side, what is going to be our limit? We got 1 vote for positive infinity. What's everybody else thinking? Does that look like a good response? Positive infinity there? Yep, good. Isaias agrees, and I will third that. I I also like positive infinity for that limit. All right, 3 parts to question 7, A, B, and C. Let's get you guys a little bit more active than just in the chat bar here. Let's have you guys put your answers on the board, and once we have answers for all 3 parts, we'll go through them as a group and see if we agree or disagree with each other. Even if someone already has an answer there, feel free to put yours in the space provided. All right, looks like you guys agree with each other here, which is good. So the limit as x goes to 1 from the left-hand side, I'm all about my highlighting here, that is approaching a positive 1, so that looks good. The limit as x goes to 1 from the right-hand side is approaching a positive 3, which means the limit as x goes to 1 as a whole does not exist because 1 and 3 are not the same value. So that will not exist then. So does not exist, or DNE. Perfect answer there for part C. Any questions with number 7? Only 2 left to go. All right, this next one, question 8, tells you to find the limit of the function by using direct substitution. So direct substitution, I don't see a fraction there, which is good. That means I probably don't have to cancel anything out. And hopefully when I plug it in, I will get a value. So if I substitute 1 in for x, let's see what that simplifies to. All right, and you guys are a lot faster with that than I am, and rightfully so there. Good job. We do get a limit of 7. All right, next one, we're also going to use substitution, but the fraction makes me a little bit leery, right? Generally, when we have a fraction, we have to simplify before we can use direct substitution. So I always want to look to see if I can simplify before I substitute in. If I didn't notice that I could possibly simplify this and I did substitution, I get 0 in the denominator. Anytime we get 0 in the denominator, a red flag goes up. It means the limit does not exist, or it's possibly going to positive or negative infinity, right? So a red flag should go up anytime you get 0 in that denominator. But luckily for us, and I can see the chat lighting up here, just waiting for that question, what are we going to do to try to simplify this? Yeah, it's your difference of squares factoring pattern, which is going to break down into x minus 5, x plus 5. And I could see everybody was just waiting to hit the enter key there. Let's go ahead, remove the x minus 5. That will cancel out, which leaves me with just the x plus 5 left over. And now at this point, we should be able to use direct substitution. So what are we going to substitute in for x? We're going to plug a 5 in because that's what x is going to. So 5 plus 5 gives us a grand answer of 10. So the limit here should be 10. Yikes. All right, that should be it. Any questions with those limits that we took a look at here today? You guys did a great job. We spent a couple of days on this, almost a full week on the topic, so I wouldn't expect nonetheless, but I can definitely see that these are starting to sink in. Now, a couple of things before you go today. So obviously get this assignment submitted. Rebecca S., if I know you already turned yours in, so if you take screenshots, I'll open the PowerPoints up. If you take screenshots and email them to me, I can give you full points back for any questions you got wrong. I want to grab the textbook. I just want to, before you guys go and study for the Unit 10 test this week, I just want to point out some formulas that you need to keep in the forefront of your mind here regarding some of the earlier lessons, like 10.1 and possibly 10.2. More or less the 10.1, because 10.1 we were trying to find the derivatives at a certain point or the derivatives of a function as a whole, right? So there were a lot of different formulas that they gave you to help you find the derivative using limits. I would focus on the box that is at the bottom of page 758. So the formula at the bottom of page 758, you're going to want to use that definition of a derivative as h goes to 0. Of f of a plus h minus f of a all over h. So if you are looking for a certain point, use that last box on page 758. If you're looking for the derivative of the function altogether, not at a specific point, please use that formula at the bottom of page 759. Okay, those two formulas are going to be kind of the key, I think, to your success of finding the limits using, or finding the derivatives using your limit process. Okay, so I know they give you a lot of other formulas, but those two are going to be really key and the ones I want you to kind of focus on your test if you need them. Okay, 10.2 is your integrals. That's your area under your curve. If you have a straight line that you're trying to find the area under, remember, hopefully that's just going to be a quadrilateral or a triangular shape. So you can use a quick formula to find that. But if it actually is a curved line, you have to create rectangles to find the areas using that. So that's your kind of summary of the lesson 2. And then lesson 3 was all this limit stuff that we looked at here today. Okay, any major questions with Unit 10 here as you study for the last unit test of the school year? Okay, we are going to finish a little bit early today. So like I said, Thursday's class then, if you were exempted from your final exam, you do not need to attend Thursday's class. I will not be taking attendance. However, if you are taking the final exam because you're a senior or you decided to use your final exam pass on a different class, I would recommend coming Thursday. It will not be a full hour class or anything like that, but we'll review what you'll see on that final to kind of prepare you a little bit better. All right, that's all I got for you today, so I'll wrap up and let you go. Have a great rest of your week. Good luck on the Unit 10 test. If you want to come Thursday and do corrections or whatever after I talk about the finals, you guys are welcome to do that as well. So kind of plan accordingly and adjust your schedule if need be, because we'll have we'll definitely have some time left over Thursday if you need to speak with me one-on-one to do corrections or whatnot. All right. Have a great rest of your day, you guys. Enjoy the sunshine, and I'll see some of you Thursday morning. Bye.